I'm Alexei from AD, and in my talk I introduce POGEMA, a sandbox for challenging, partially observable, multi-agent pathfinding problems. Multi-agent pathfinding, MAPF, is a challenging problem with typical applications in video games, logistics, etc. The intrinsic assumption of what is called classical MAPF is that there exists a central controller. That controller gets all the information about the agent and the environment. In many practical applications, it's impossible to deploy a reliable infrastructure for such a centralized MAPF. For example, coverage of areas such as nuclear plants, mines, disaster areas, etc. For that purposes, we propose POGEMA, the environment for partially observable MAPF. A typical PO MAPF instance in the POGEMA environment is presented in the right figure. The agent for whom the path is being constructed is indicated by a red cycle. His goal is a white cycle on the right with a red border, and his area of observation is a square with an intermittent red border. Static obstacles are shown in gray and other agent in turquoise. The task is to construct a policy which maximizes the chance of an agent to reach his goal. POGEMA provides classical for RL interaction scheme via OpenAI Dream or Petting Zoo interface. Observation space is presented by three matrices for obstacles, agents, and target or its projections. The agent receives a reward of +1 when it reaches the goal. This reward is easy to interpret as it corresponds to the individual success rate metric for each agent. And we have a second metric. It is cooperative success rate, which is equal to +1 only if all of the agents in the interaction episode have reached their goals. Surprisingly, there are not many multi-agent grid-based environments that fit the definition of PO MAPF. The closest one is a flatland environment, but it is rather slow and is not geared toward partial observability. We define a set of standard configuration for benchmarking PO MAPF algorithms. The instances use 30% obstacle density and different difficulties based on the number of agents on the map. The simplest configuration in the whole set has 8 to 8 size with only one agent, and the hardest one is 64 to 64 with 520 agents. Of course, one can easily adjust all the parameters. Also, POGEMA provides a simple and intuitive way to prepare custom maps. The example from well-known forums domain are shown in the slide. We've prepared 3 types of baseline for POGEMA. First one is a centralized training method, which is commonly used in multi-agent reinforcement learning. We provide pi-MARL implementations of such algorithms as QMix and VDN, and independent co-learning, the centralized one, which results emphasize the requirement of cooperative behavior of the agents. Besides small PO MAPF tasks, POGEMA is suitable for large-scale reinforcement learning experiments. In this experiment, we trained asynchronous proximal policy optimization with 100 million steps. A fast environment and distributed RL framework allows us to train RL agent in a few hours on a single GPU, even using ResNet encoder and recurrent heads. And finally, we present the results of the planning baselines. We use the A-star algorithm and also add several ad hoc heuristics, which makes the algorithm competitive in the multi-agent setting. As one can notice, in contrast to RL baselines, A-star perfectly solves configuration with a small number of agents. Thus, we believe the combination of RL and planning methods will leverage the current results. Our code is open sourced and available at GitHub. Thank you for your attention.